So this is activity 3 and I think I assigned this as your assignment. So this is how you check your work if you got the correct answer or you've been very careful in sketching the vectors or adding the vectors. We basically have three vectors here. We have vector I. So let me just look for yeah. So vector I is 180 units, 45 degrees east of south. The second vector is vector D, 30 units, 60 degrees east of north. And the third vector is S, 120 units, 30 degrees north of east. Okay, let me just fix that smudging because I hate it. I hate looking at the smudge. Okay, I cannot fix it unfortunately, so let me just live with my hate of the smudge right there. Okay, now if you also notice about the vectors, about the very first thing that we have to do is to set the scale, and I'm hoping you can observe, or you've been very keen to observe, that 180 units, 30 units, and 120 units are actually multiples of 15. So that's one of my clue in terms of the scale that I'm going to use. So I'm gonna say that every 15 units, this is coming from my vector, is equivalent to 1 cm on my ruler. So that means to say that all of these vectors will simply be 12 centimeters, 2 centimeters, and 8 centimeters. Another thing is that we have to be wise where we place our original Cartesian plane. And let me just define the directions again. So I'm just being consistent over here. So this will be my north. This is my east, south direction. This is my east. Okay, that's messed up. So let me just fix that. This one is east, and this one right here is my west direction. And another thing is you have to look at the direction of the given vectors. So east of south, east of north, north of east. So again, this is telling me it's on the second and third quadrant, if I'm right. We have fourth quadrant, okay. East of south is, yeah, on the fourth quadrant. So that means to say I'm going to place my Cartesian plane on a different side so that I can maximize the space. Unfortunately, I don't really know how to do it, so let me just figure it out. Does this work? No, not like that. So maybe the entire thing. Yep. No. Okay. Okay. This one is, yeah, good. Should move it somewhere here. All right. So I did that because I want to maximize the space. So let's go. This is tail to tip. So basically, we're adding vectors. The tip of the first vector should be the head of the second vector, and so on. So let's start with the first vector, and our first vector is 180 units, 45 degrees east of south. So from south going east, I'm going to place again my protractor where the 0 degree should be from south, because I should be going from south going east. So this is how I should orient my protractor, where as you can see here, the 0 degrees is along the south direction. I should go east, so with 45 degrees. Means to say that this right here is my 45 degrees. I'm hoping you were able to see that. It's actually a little bit, should be here. Yeah, there. And then from the scale that I have had earlier, I just have to measure 12 cm from there. I'm gonna pick my ruler, and then where's the 0? Where's the 0? Here. 0, and it should pass through both the origin and the dot, which signifies the angle. So right, nope, nope, maybe like that. Move a little bit. Okay, there. And I have to, okay, okay, there. All right. So I have to measure 12 cm, and I'm going to use red for my first vector. Okay, I don't want to smudge or anything, so 12 cm is exactly there. So that right there is the head of my first vector, and that is my vector I. And if we want to like indicate the direction is this one. This one is 45 degrees, and that's east of south, right? East of south. Okay, now we basically know the process. The second thing that we have to do is to set again our new xy plane to define our directions. So this one right here, and then also that, to make sure you have the alignment right. Otherwise you'll mess up the magnitudes and the direction that you're going to measure later. So let me just, oh no, should be just that and that. Okay, now again I always say consistency is key here. So this will still be my north, this one will be my south, this will be my east, and this will be my west. You cannot interchange the direction, but you can actually change the direction from the very first vector and follow it throughout. So what I say, consistency is key. So for the second vector, the second vector is east of north. So again, that means I'll start my 0 degrees from north going towards east, and clearly that's on the first quadrant, and have 30 units. 30 units according to my scale will just be 2 cm. So I'm going to grab my protractor and situate it in my new xy plane just like this, and I should note that the 0 degrees must be on the north. Am I right? North? East of north. Yeah, from north going east. So I have to measure 60 degrees going east. Now, if you can see here, right here, so this one is 0 degrees, and on my north, I'm going to measure the 60 degrees going east, so I should move along this direction. I need to find east. I'm using another color, violet, for this one. 60. All right, so this is 10, 20, 30, 40, 50, 60. 60 is right here. I'm going to mark this. Okay, that's 60. Actually, it's like 60.5. So let me just fix that. It should be 60, exactly 60. All right. Or not, yeah, 60. So now that I have marked where 60 is, we do the same thing. We set our ruler such that it passes both the origin of our direction, and then it also passes through the point which denotes the angle. So just like that. So I'll measure 2 cm from there. So just 1 and 2. Okay, and then this is my second vector, vector D, and the angle is this one. I think I forgot to label the angle from the first example. Oh, you should note that you should always do that for ease of checking. Okay, so we're down to the third vector. Again, this is just repeating. The process is basically repeating itself. We do the xy plane to indicate the direction again along the last vector that we added. So this right here, and then make sure that we have a very straight line there. Kind of notice that my accent changes when I'm recording. I cannot do this talking like this in real life. It's because it's gonna be, I have to talk loud, so I cannot do this. Anyway, those are just some things that crosses my mind while I'm doing this one. All right, so again, still consistency: north, south, east, and west. So the third vector which we have to add is actually vector S. It says we have to represent 120 units, 30 degrees north of east. So again and again, I've been doing this again and again. I'm hoping you already get this one. We start from east. Sorry, let me just erase this one. We start from east going north. That means our 0 degrees on the protractor must be on the east direction. So this is my xy plane to indicate my direction, and I set the 0 degrees and east, and I have to measure 30 degrees going north, right? So I have to go north. My angle measurements are 10, 20, 30. That's 30 over there. So I'm going to use blue for this one and mark 30. So 30 is along this. Okay, and I'm just going to move the protractor. 120 units, if I'm using this scale right here, is simply 8 cm. So we do the same thing with what we did earlier. I'm hoping this will not overlap to the next page. So yeah, right here, please do not overlap. Oh my goodness. Oh my goodness, I think it will overlap, but I can easily move the vectors. So as you can see, it will just be a straight line, and I'm going to explain why later if we try to connect this with your geometry class, why the two vectors are actually just forming a straight line right here. Maybe you encounter this first in geometry before I'll talk about this one. So this is 8 centimeters right there. Oh my god. Yeah, it's exactly 8. This right here is 8. So that is 8. And this is my vector S. And my angle is here. 30 degrees. And this is north of east. So 30 degrees north of east and 60 degrees north of east. They have some things about the two angles which we'll discuss when we will reach in relating it to geometry. But for now, let's just leave it at east and make the observation that they actually make a straight line. Anyway, so we got our three vectors there, and as we know already, our resultant vector will be measured from the very origin that we set until the tip of the last vector. So I'm just going to orient this properly so that I get the correct measurements. So that's 0. You have to tilt this one a little bit. Okay, it's not responding, or I don't know. Oh yeah, it's responding, but just have to be very precise. Nope, it's not that precise. We move a little bit. Oh, come on, it's not that responsive, or I'm getting very OC about the measurements. Okay, it's so annoying if it's not responding. Right, but we have to move this down, otherwise we will get the wrong measurement. This is really the hard thing about doing geometric method, is that you have to be very precise with everything, the measurements, the scales, the sketches. Okay, come on guys, root for me so that I could have this correctly straight up. Okay, that's not it, so we move a little bit like this, or like that. Yep, I think that's good. So we have 17. I'm hoping. Oh, okay, it was a bad move. Right. So let me just use a dotted no strokes for that, and use a different color, maybe pink. Yes, pink. All right. So from here up until this one is my resultant vector, and that's 17.4. So I'm going to write that as R, the resultant vector, meaning that's the sum of all the vectors. And I noticed that, I'm going to write it here, the magnitude is 17.4, that is in centimeters. So I have to remember that I have to multiply it by my scale. Every 1 cm in my scale is 15 units, so that I'll return the correct magnitude, which is in terms of units. So from what you can see, the centimeters will cancel out, and 17.4 multiplied by 15 will give me 261 units. All right, so that's 261 units. I'm hoping we got same magnitude, or at least very close to this one. So it could be 260. Maybe we can forgive 259 or 262. And then for the direction, we were still going to get the two possible answers for the direction. The first one is where I will set my 0 degrees. Guess what? From my east, the small angle. Where's my 0? Okay, where's my 0? Here's my 0. Rotate. Okay, and there. Zoom in. Alright, so let me just, I think it's offset by a very small angle, but I cannot be very OC about that. I just change the color to green for emphasis. Now, I could get this very small angle over here from the east direction going to my vector and name it theta 1. So theta 1, as you can see, is at 11 degrees, and I started it measuring it from east going south. So this is gonna be, I have here magnet direction. So this is a vector, it involves both. I could say 11 degrees, I started from east, was it? Yeah, started from east going south. So that's gonna be the south of east. Remember this one? Started from east going south. Now the other angle is basically just the complement of that angle, is where when I will try to measure the angle by situating the 0 degrees along my south direction. So as you can see here, when I orient my protractor like this, I get the second angle. So basically just have to pick one which is more convenient for you. This one right here, okay, I'm going to use still green. This one right here is my theta 2, and as you can see, it's a 0, 10, 20, 40, 50, 60, 70, 70, this is 75, 76, 77, 78, 79 degrees. So it could also be reported as wait, what's happening? 79 degrees east of south, since I started from south going east. And take note, as I've said from the other video, the two vectors, the two directions are complements. So that means if we add it together, they should be getting 90 degrees, right? So that's it for your assignment. I'm hoping you did have the same answer as mine.